Hi, in this part of the lab, we're going to measure the RC circuit response with a short ramp input. So, to do that, we're going to use the waveform generator to generate the ramp function, and then we're going to view the output on the oscilloscope plot. So, let's head over to our waveform generator. Now, in order to generate a ramp, a short ramp input, we're going to have to build a custom waveform because a short ramp input is not built in the WaveGen, and it cannot be done using a simple configuration. So, change the configuration type to custom. Hit new, and then it should take you to this window where we can change different parameters to build a custom waveform. Make sure you're on the function tab since we're going to build it using a combination of different existing functions. So, the first thing to do, the very first thing, is to take normalize off. This is very important because what normalize does is it makes it symmetric between -1 and 1. Now we don't want it to be symmetric between -1 and 1 because we're going to have a ramp that starts at 0, goes up to a certain point, and then goes back down to 0. We do not want it to be symmetric with respect to the time axis, so make sure that normalize is off. Now, we're going to have our ramp be on for 10% of the period and off for the remaining 90%, sort of like what we did in the previous part. So change the length to 10%. Now, we're going to use type ramp up because ramp up is a pre-existing type that produces a triangle wave that can have a flat portion on the top. So type ramp up. We're going to change the amplitude field to 50%, and we're going to offset it by 50%, sort of like what we did in the previous part. And that is it. Let's click generate, and here's our ramp input. Since this looks okay, this is what the kind of waveform that we're looking for. Let's click OK, and you see that waveform has now populated into the WaveGen. So, with that set, let's head back over to our oscilloscope plot. We're going to change the base to 1 millisecond per division. We're going to change channel 1 and channel 2, each one of them to be 500 millivolts per division. 500 millivolts per division. And let's make sure our trigger is set correctly, 0.5 millivolts. Now for this one, we're going to use a falling condition as opposed to a rising condition. Source is channel 1. The mode is repeated and normal. Looks good. So let's click single. So, actually, I skipped a certain part of the instructions, which is why we see that keep repeating. I created the custom waveform. Now I still have to configure it in this menu. So, since the ramp is only going to be on for 5 milliseconds, the period is going to be 50 milliseconds, which means that we're going to have to use a frequency of 20 Hertz, and that comes from your lab handout. So let's change the frequency to 20 Hertz. Make sure it doesn't say 20 kilohertz. 20 Hertz. And since the formula for the function that we're trying to build is 200t times u of t minus 0.005. Now, at 0.005 seconds, 200 times 0.005 is 1. So we can leave the amplitude at 1 volt, and we'll get the correct waveform. Now let's head back over to our oscilloscope plot and press single, and you should get some output looking similar to this. This is exactly what's expected. In the pre-lab, you computed, using the convolution integral, the ramp response of the RC circuit, and as we can see, it's consistent with the pre-lab results. So, we're happy with this output. It looks clean. So let's head over to export, save the image, click save here, and then save the CSV data by clicking save. Once you're done, close out of the export window, and we have completed section 2.4 of the lab. So the last part that's left is we're going to measure the response of the RC circuit to an external sinusoid, and we're going to use that to sort of get a feel for the frequency response function HJ omega of the RC circuit. And we'll do that in the next video.